So here is our second study guide. So question number 1 says, for a quadratic function in the form f of x equals a parentheses x minus h squared plus k, what does the a do? So the a tells you if it opens up or down. You know it will open up when it's positive. You know it will open down when it is negative. It also tells you if you have a vertical stretch or a vertical compression. So you will have a vertical stretch when the a is greater than 1, and it's the absolute value of a, because the negative would only tell you it opens down. And if it is between 0 and 1, then you have a vertical compression. So vertical stretch meaning the graph would look skinny, vertical compression meaning the graph is going to look wider. So what does the h do? This does the left and right shift. And it's backwards from the coordinate grid. So you go left when it's positive and right when it is negative. So what does the k do? That does your up and down. Up when it's positive, down when it is negative. What does h comma k represent? That is your vertex. Okay, question 2. What are the intercepts of the graph? They want you to list both the x and the y intercepts, even though it does not specify that. So you want to look on your x-axis. We've got 1 here, 1 there, and 1 down there. So you're just estimating these. So this one right here would be negative 1.5 comma 0. You would pick any number that was between negative 1 and negative 2. This one over here would be positive 1.5 comma 0. And your y-intercept would be 0 comma negative 6. They will try to trick you and flip-flop these things, so just make sure that the 0 is in the correct spot. So x-intercept 0 goes last, y-intercept 0 goes first. Question number 3. Draw a graph symmetric to the origin. Draw a graph symmetric to the y-axis. So for the origin, this is always my most favorite one. I just draw the cubic function. How do I know it's symmetric to the origin? Well, if I flip my paper upside down, it looks the exact same as if my paper was flipped normal. So that's how I would determine this on the test. So flip paper 180 degrees and it looks the same. Okay, draw one symmetric to the y-axis. So that would be your basic U. Mine's not drawn perfectly here, it's just a rough sketch. But basically, however many spaces you are away from here, it's the exact same number on the opposite side. So that would give you y-axis symmetry. Alright, draw a graph symmetric to the x-axis. So we'll just draw our U sideways. So these would be equal number of spaces. I'm not going to take the time to make sure that they are, but basically what looks the same on one side will look the same on the other. So if I folded my paper in half, they would be identical. Draw one that is symmetric to the origin, y-axis, and x-axis. So most common one, and it's hard to draw it perfect, would be your circle. So your circle is symmetric to all three. Okay, number 4. Identify the center and radius of each. So I have x plus 11 squared plus y minus 9 squared equals 19. So your center, you're just picking these numbers out right here. Of course, the x1 needs to go first. You need to change your sign. So negative 11. And then this one would be your y1. So that would be 9. You have to change both signs. Okay, your radius, you look at this right here and you would square root it. So don't forget to square root it. I would probably guess that this would come out actually perfectly, like it would be a 4. And so that one of the answer choices would be 4, and you would forget to square root it and the actual answer would be 2. So I would almost guarantee that on the test that this would probably come out perfectly. All right, question number 5. Find the center and radius of the circle. So on this one, you're going to need to complete the square. In order to complete the square, you need the number on the opposite side. So my first thing is to subtract 296 on both sides of the equation. I want to put the x's together on the one side and then the y's together right behind it. So I'm going to rearrange my equation here. I'm going to leave some space so I can complete the square. Leave some space there to complete the square. Okay, so to complete the square here, we're going to take this number, divide it by 2, and square it. So I have negative 14 divided by 2, square it, add it to both sides. Okay, then I'm going to take this number here. I'm going to do the exact same thing. I'm going to divide it by 2 and square it. Do that to both sides. Okay, then I need to get my answer together. So what I'm going to do is I'm going to take this x and this right here. I'm going to put that together. But you want to ask yourself, what is negative 14 divided by 2? Well, the answer to that would be 7. And then I'm going to take the y and the 32 divided by 2 and put those together. So 32 divided by 2 would be 16. Okay, so this would be 7, so 7 squared would be 49. This one over here is 16, and 16 squared would be 256. So negative 296 plus 49, and we're adding these here, plus 256 would give me 9. And then I just need to find the center, so don't forget to change your signs. So you're looking at this number, so 7, and this number, we change our signs, negative 16. And our radius, and this is probably more what I would see on the test, it's going to be 9, but you have to square root the 9. So the real answer that would be on the test that you'll be looking for is 3. Okay, question number 6. Does the relations represent a function? So basically you are looking that each input in the domain has one output in the range. Okay, so 1 goes to C, 2 goes to D, 3 goes to C. That's okay because it's only going to one number, not 2, or letter I mean. 4 goes to A and 5 goes to E, so this is yes. So each input had only one output answer. Okay, domain, each input has only one. Well, 1 goes to both A and B, so this is no. And the reason is because that input had 2 outputs instead of only one. Number 7, this comes up a lot on all of the tests and including the final. Find the domain of the function. So you need to set the denominator equal to 0 and solve. So negative 3x squared minus 12x equals 0. Okay, I have x in both spots, so I want to factor here. And I can take a 3 out because 3 goes into 12. And since they're both negative, I'm just going to go ahead and take out the negative also. So we'll take out a negative 3x, and I'm left with x plus 4 equals 0. So then you want to set each piece equal to 0. So negative 3x equals 0 and x plus 4 equals 0. Divide by negative 3. And I get x equals 0. Subtract 4 on both sides, x equals negative 4. So your answer on here would be all real numbers except x cannot be 0 and x cannot be equal to negative 4. Okay. If we did this in interval notation, which I don't know which way it'll be on your test, the exact same thing would be negative infinity to negative 4 and negative 4 to 0 and union is what I kind of consider as and, 0 to infinity. These are parentheses because it's not including negative 4 and 0. So you have to space in between each of the chunks there. I believe this probably would be the way they would word it on the test though. But just in case, you have that one too. Okay, question number 8. Use the graph to determine the intervals of increasing and decreasing. So when you do this, you want to list the x numbers. Okay, so we'll separate this from increasing, and then we'll have a separate listing for decreasing. Okay, I like to start all the way over here in the corner, and I just picture that there's this little roller coaster and it's riding on a track, and the graph is the track. So it's going to start decreasing. So I'm going to start with negative infinity, and I'm going to continue till I'm right here. Now I need to list the x coordinate, so I need to read that up here at the top of the graph. And that looks like it's pretty close to negative 2. So anything between negative 1 and negative 2, she won't trick you with that. So we'll go negative 1.75. Okay. So that will get a parenthesis. And this will get a bracket. All right. So from here to here is going to go up. So I'm going to start at my negative 1.75, and I'm going to increase, read the x number, not the y, up to 0. These are both included because there's no gap or open holes. Then from 0, and I'm going to read this down here on the y, to 1, we go down again. So 0 to 1, we're going down, and then 1 to infinity, we're going to increase. And remember, infinity always gets a parenthesis. All right, number 9, write the slope-intercept form of the equation through the line given the points in the slope. So through 0, 1, and your slope is 0. So 0 would be your x, 1 would be your y coordinate, and your slope is your letter m. If you remember the formula, it's y equals mx plus b. Okay, so we're going to plug in the x, the y, and the m into the formula. I need to find my b value. So I have 1 equals 0 times 0 plus b. Well, that makes this a lot easier. So 1 equals b. So I plug that back into our formula. So y equals 0x plus 1. 0 times x is just 0, so we don't even need to write that. So it is y equals 1. And there is a trick to this. Because the slope is 0, the trick is you just always list the y coordinate. And that will happen every single time. So if I had made the 1 be 3, our answer would be y equals 3. All right, now, as a little side note here, if they told you the slope was undefined, you can also use the little trick and do this very quickly. It would be x equals, and you pick the x coordinate. And in this particular case, it would be 0, but in general, if it said the slope instead of 0 was undefined, whatever the x coordinate is, you would say it's x equals the x coordinate. So those are two little tricks in case they give you something that is more uncommon. Okay, question number 10. Write the slope-intercept form of the equation of the line described through -1, -4, perpendicular to y equals x plus 3. Okay, so I like to start with listing out my slope. So my slope is 1, and I'm just going to go ahead and put that over 1. So my perpendicular slope, basically, if it's perpendicular, you have to flip and switch the signs. Okay, so our perpendicular slope would be just -1, because flipping 1 over 1 is still just 1. Go back to your formula, y equals mx plus b. So this would be your x, -1, -4 would be your y, and we're going to use the perpendicular slope into our formula. So I have -4 equals -1 times -1 plus b. So -4 equals -1 times -1 is 1 plus b. We're going to minus the 1 on both sides, so -5 equals the b value. Then we need to plug this back into y equals mx plus b again. So y would equal, and when you plug this in, it's really important to make sure that you use the perpendicular slope and not the original. I can guarantee you she will try and trick you on there. So make sure you're putting that one in. So this would be -1x minus 5. That would never be the answer on the test, so it would just be -x minus 5. And that would be the answer you would select on the test. Now, if it had asked for parallel instead of perpendicular, as a side note, parallel just means you keep the same slope. So whatever slope they would give you if it was parallel, you would just write that slope into your formula. All right, number 11, write the standard form of the equation for the circle. So what you want to do is you want to figure out what is the radius. So in order to do that, you're going to start from the center and you're going to use the grid. So I've got 1, 2, 3. So I know my radius is 3. Then you want to pick off the center of your circle. So if I look, I'm at 4. And then I'm going over and up 4, so it's 4, 4. I'm just using the grid to help me count. So my center is 4, 4. So when you plug these in, you need to switch your signs. So it would be x minus 4 squared plus y minus 4 squared. So you need to remember, when you're plugging the x with the x and the y with the y, you switch the signs. And your radius is this, but you need to remember you need to square it. I can almost guarantee you that this would be an answer, and instead of it being 9, which is the correct answer, they'll have 3. So that's pretty much a guarantee. So you need to remember, from there to there, you got to square it. Okay, number 12, solve the absolute value equation. So the first thing you need to do is move the number to the opposite sign. So I need to minus 3 on both sides because I need to move it from here to over here. So I have the absolute value of 3 plus 6n equals, and 24 minus 3 would be 21. Okay, then this gives you 2 cases if it's an absolute value. So I have 3 plus 6n equals 21. And I guarantee you that everybody gets this one, but they forget there's absolute value has 2 answers. So it would be 3 plus 6n equals negative 21. So you have to solve it with it being positive and in the negative. All right, so we'll minus 3 on both sides. So 6n equals 21 minus 3 is 18. Divide both sides by 6. I get n equals 3. Over here, it's the exact same process, so minus 3 on both sides. 6n equals negative 24. Of course, we're going to divide by 6. So I get n equals negative 4. Okay, make sure if you get an absolute value, you have 2 equations. Now, on a side note, let's pretend that this was the problem they gave you. Absolute value of 3 plus 6n plus 3 equals negative 24. Okay, again, we would subtract 3 on both sides. So I get the absolute value of 3 plus 6n equals negative 27. And if you get a negative, if you have the absolute value on one side and a negative on the opposite, then it is no solution. You can't have negatives on this other side. Just as a side note. So no negatives on the opposite side. If you get a negative there, it's no solution. Okay, number 13, write the absolute value, equality, or inequality for the following statement. X is more than 2 units from 7. Okay, so here's my number line. Sometimes it helps to see a number line. Okay, so x is more than 2 units from 7. So here's our 7. right here, and we're going to be more than 2 units. Okay, so what we're looking at here is the absolute value of x minus 7 is greater than 2. Okay, so we need to solve this. So I have x minus 7 is greater than 2, and because this is greater, this is your or clause, x, let's pull that out, x minus 7 is less than negative 2. Okay, so the or clause means that you keep one that's greater, one that you flip the sign and change the other one to a negative. So we're going to add 7 to both sides. So x is greater than 9. That's probably the case that you would recognize. Okay, so we would be greater than 9. Or if I add 7 to both sides, x is less than 5. So this is an or clause. Okay, so this is the answer that you would pick. Okay, so if you look at this 7, here it's more than, and over here it's also the same. All right, let's look at the next one, number 14. Name the types of functions for each graph given below. So one of the versions of tests that you may see is a picture of a graph, and then it basically said it's matching. So you kind of would match the answer there. So first one is just, it's hard to see here. It's a straight line going across. This is a constant. Okay, the one that looks like that is a cube or cubic. The V would be your absolute value. Straight line going diagonal, linear, as long as it's not horizontal. One that's sideways like that is square root. One that's sideways like this would be the cube root. Okay, one that looks like that would be square. It just depends on how they're going to word it on the test. Quadratic. Or as we know, a parabola. And one that looks like that would be reciprocal. All right, number 15, describe the types of functions below as either even, odd, or neither. So even is the first one. Even has y-axis symmetry. So it's equal distance from this side to this side. You folded your paper in half. It would look the same on the y-axis. Okay, odd or origin symmetry is where you would turn your paper upside down and it looks identical to when it is not upside down. So this one would be odd origin symmetry. Okay, and this one here, if you turn your paper over like this, it would have neither. Okay, and we're going to add one off to the side here, just as another example. So let's say I had a U off to the side. If I fold my paper diagonally on the y-axis, this would be neither because the U has to be right on the y-axis. So this one is neither. So they may try to trick you. So don't get in the habit of thinking, oh, it's a parabola, it has to be even y-axis symmetry. That's not correct. If it's shifted, then it makes it neither. Okay, 16, identify the domain and range for the following functions. So this first one, your domain, you're looking at everything on the x's, so it would start here at -3, and it would go all the way over to infinity. Infinity gets a parenthesis. Since this doesn't have an open circle, that's going to get a bracket. Your range is everything on the y's, so I start here on the y. We start here. I need to read the y coordinate, so that would be 0. And then it would go all the way up to infinity, because this is going to keep getting taller and taller and taller. Infinity gets a parenthesis. 0 will get a bracket, because that is closed right there. Okay, the U1 over here, domain, because this keeps spreading out over and over, it will eventually cross the entire x-axis, -infinity to infinity. The range, I start from the bottom. I'm going to come over and read the y-coordinate, so that would be 4 to infinity. Infinity will get a parenthesis, 4 will get a bracket. Okay. This one down here, the domain, because it spreads across the entire x-axis, will be -infinity to infinity. And the range, we need to read here on the y, would be -2 up to +2. And both of those would get brackets because the graph is closed circle. All right, and the last one over here, the domain, this spreads across the entire x-axis. So that would be -infinity to infinity. And the range, you want to start from the bottom. So I come up to the lowest point, read the y-coordinate, -2. And the graph will keep going up towards infinity. Okay, because there's no open circle there, this is going to get a bracket, and infinity will get a parenthesis. Number 17, give the domain of the function. So what you want to do is you want to look for the square root, and you're going to set that piece equal to 0. So I have x minus 1 is greater than or equal to 0. So we will add 1 to both sides. So x is greater than or equal to 1. That would be your domain. So we would have 1 to infinity. All right. If you would go to graph this, remember square roots look something like that. So they would have a starting and then an ending. This one in particular would start somewhere at 1. Okay. All right, number 18. The graph of f of x is given below. What is f of 3? So basically you would come down, find 3 on the x-axis, go down, read your graph, which looks like it's right there. Read the y-coordinate over here. So f of 3. And if I come all the way over, that's a -4. Okay, so I just come over to the 3 and then come over and read it off the y-coordinate. All right, number 19. They give you 3 different cases. They want find f of 1, f of 4, and f of -1. So f of 1, you have to read your cases. So this doesn't have a bar, so it's not equal to 1. This is greater than 1. This is the one that says x equals 1. So your answer for f of 1 would be 2. Okay, f of 4, you need to figure out which one the 4 case would follow. Well, this is between -3 and 1, and this is x is greater than 1. Well, 4 is greater than 1, so I want that middle case. So this is going to be 4 squared, and 4 squared is 16. Okay, and the last one, f of -1. Well, -1's between -3 and +1. So f of -1 would be, you'd have this minus on the outside. Anytime I plug in my number, I put it in parentheses, +1. So I have negative parentheses, -1 plus 1. Those two negatives will indeed cancel. So basically we're just looking at 1 plus 1, and 1 plus 1 is 2. Okay, and question number 20. Which of the following points lies on the graph of, and they give you an equation, f of x, x to the third minus 9x divided by 4x squared minus 4x. And notice, look at, this is one where you have to use your answer choices to get the answer. So all of these are 4 in the x coordinate. So what I'm going to do is plug 4 into all of the x's, and then it will pop out either -1/2, +1/2, 5/12, or 7/12. Okay, so we're looking at f of 4. So we're looking at 4 to the third power minus 9 times 4 divided by 4 times 4 squared minus 4 times 4. Okay, 4 to the third power would be 64. 9 times 4 is 36. Okay, again, 4 squared times 4, that's the same thing as 4 to the third power. That's 64 again. Minus 4 times 4 is 16. Okay, so I get this. 64 minus 36 is 28. 64 minus 16 would be 48. And if you would reduce this fraction here, you will get 7/12. So your answer would be D. Okay, and remember there is 20 questions on the test, and they are all multiple choice. And they will be 5 points apiece. All right, good luck, and remember, every time you open a version of the test, the questions are all different, so I can never give you a copy of the exact test, but hopefully some of them would be similar to this.